Today's episode is brought to you by Focal, a global leader in high-fidelity solutions since 1979. Focal presents the new Clear MG headphones, an upgrade of Clear with sharper sound reproduction in sophisticated chestnut tones and metal accents at the same price. Be part of the Focal experience at focal.com. Today's episode is also sponsored by Shit Audio. Shit Audio designs and builds audio components in California. Based in Valencia, their wide line of amps, DACs, and audio accessories fit any budget, starting at $49. For a full rundown of all their products, visit shit.com or stop by their retail store in Old Newhall, just north of Los Angeles. That's www.schit.com. Hello, friends. You have reached the Occasional Podcast. Please leave a message. Just kidding. You have actually reached Season 5, Episode 5, our big wrap-up educational piece on media servers. So welcome. It's going to be a crazy ride. We got a bunch of information ready to throw at you. Really, almost everything you've ever wanted to know about media servers. And special thanks to our friend Nuno Vitorino joining us from Innuos to help supplement our knowledge on the subject. But first in the news, all of our lovely audio shows have ended up congregating near third and fourth quarter of this year. And that's even if things clear up for the pandemic. So for those looking to rejoin your fellow audiophiles and audio shows, Expona, Capital Audio Fest, everything in the U.S. really is now clumped together near the end of the year, all in hopes that we'll make it together somehow. But I have faith that we will all get to see each other again. But, just keep an eye on the websites for date updates and changes on that. Because, a lot of these shows have already shifted a couple of times. But I'm, for one, am hopeful. And I would very much like to get together and listen to some high-end systems and see your lovely faces. Also, in terms of new product releases, Macintosh recently launched the MHA 200 headphone amplifier. And this is a cool-looking little headphone amplifier that mimics the MC 275 large-size amp they have. Also, on the headphone front, Audizy's introduced a new closed-back planar magnetic IEM. They used to have these open-back ones that are pretty fun. But now they finally managed to get it all worked out to have it a closed, sealed kind of thing. And the lower profile doesn't have quite that TIE Fighter look anymore. So it looks like a regular IM. And on the subwoofer front, SVS has two new products to talk about. That is the new 1000 Pro series. They redid their entry-level, their very popular entry-level line of speakers. They have a sealed and a ported in the 1000 line. Those are out there, brand new. In addition to that, they also did the mini. So they have a 3000 micro, they call it now, from SVS, which is like one of those under-the-desk kind of things that would really pair well with a pair of computer speakers. And one of my favorite little things to kind of add to the market in terms of portable listenability, Estelle & Kern unveiled a USB-C dual DAC cable. It's called the USB-C dual DAC cable, which is a USB-C connection, so not good for iPhones, but for your computer, a laptop, a MacBook Pro perhaps, like we have here, you can just plug that in, small dongle, goes to the DAC with pretty sufficient power to the headphones, plug your headphones in the other end, and there you go. So better sound while listening to your laptop. Also, Android phones with a USB-C, plugs right in, you can use it in that thing. So they put a lot of thought into it. You can, of course, see all these updates on audiohead.com, audio-head.com, and parttimeaudiophile.com. News constantly rolls out. There's tabs at the top. If you just click on the column, news, and it pulls up all the fun stuff. So that's it for product releases. I would also like to mention that our friends over at Zoo Audio are priming their Omen Dirty Weekend sale for their full-range Omen loudspeaker. That's going to start March 25th at 12 noon Mountain Time. If you want to get in on this, you got to be pretty quick. Sale is limited, sells out fast. Mark your calendar. The prices start at a cool $999. They have a special landing page if you want to try to grab a pair. That's zooaudio.com/ODW. That's ZUAUDIO.com/ODW. ODW. Omen Dirty Weekend, I'm assuming that stands for. So now as we say, on with the show, here we go. Nuno Vitorino from Innuos. Everything you ever wanted to know about music servers. Hit it. Thank you so much for joining us today. Our episode this week is Everything Makes a Difference, Music Server Edition. And our guest on the podcast is Nuno Vitorino, director at Innuos Music. How are you?
Brian, I'm very good. How are you? Thanks for having me.
How did I do with your last name? Am I getting better here, or was I off?
You're getting a lot better. You're getting a lot better. A lot of people just don't get it. It's a global world these days. You
That's
have to know names in every single language.
You work for Innuos. What country are you guys based out of?
We are based out of Portugal. We started in the UK when I was living in the UK. So the company started as being an English company. And as we developed, we then moved part of it to Portugal. So the main headquarters are now in Portugal. And we still have a company in the UK. And in Portugal, we have 2 more offices. So one in Lisbon for software development and one based in the Algarve where production happens. And we're looking to expand this more and more. So we're having people now in the US and people in Germany and so on. So we're starting to expand more and more. But, you know, like in today's world, we're starting to work more and more remotely anyway.
Yeah. So the reason I had you on the show mostly is because of one of your demos that you did at an audio show for me, which really kind of made me think long and hard about music servers and their impact on the overall system, was an A/B that you did with your own music server. So you did your flagship. It was when your flagship came out, I believe. And then you had the previous generation, or the one that's the tier down from that price-wise. And I gotta say, as controversial as it might be for some people from that experience, and I didn't control every variable. You were doing that, so I can't attest to how, if there's shenanigans going on in the back. But you seem like a pretty honest guy. There was a noticeable sound difference. So that is why this podcast is called Everything Makes a Difference, because I say there's definitely room for argument of how much, right? Every little part of the system makes a difference. Obviously, some, like the speaker, make a great bit of difference, whereas others make less. But I would just say, from your example, there was a difference from that A/B. And that's kind of why I was like, really started me thinking, you know, what else can be done? What is the role of the music server? Because for those less, you know, digitally inclined, you know, this is a device that feeds into usually another device called the DAC, a digital audio decoder. So it's not right. It's the true source of the music, but it's not the one that brings it from the digital domain to the analog, generally speaking, although they sometimes have outs. So I wanted to dig into your expertise with this podcast and kind of just do with like a nice easy start and kind of get a little background going and ask you, what do you think there are some of the best reasons for upgrading to an external music server or a streamer? Because a lot of these things are often packaged together, or we just use a USB through a computer. So if you could just kind of elaborate on that.
Sure. I think I would like to start just to try and understand, or try having people understand why it does make a difference, because a lot of people just ask, look, this is a digital server, it sends zeros and ones, and it is bit perfect. You know, you're not going to change. We're not changing those zeros and ones that go, let's say, into a DAC or into a streamer. Now, so why does it make a difference? So a lot of, again, there is this kind of romantic view that actually it's zeros and ones that go through a line. But it's not zeros and ones, it's actually a signal. It's an electrical signal that goes through the cable. That electrical signal is not perfect. So in an ideal world, it would be like a perfect square wave. So whenever you have a 1, it would be up, and whenever you have a down, it would be straight. Let's call it like that, just to help visualize it. What actually happens is that whole image is like trembling, like there's noise, there's interference that goes into it. So it's not enough normally to interfere with the interpretation on the other side, let's say on the DAC, that is a 0 or that is a 1. But the problem is that the DAC is an electronic system. And as any electronic system, it is susceptible to interference itself. So it's not, again, the zeros and ones that make a difference here. Those are bit perfect. You know, a computer or a music server, being it very good or not, will send the same data from A to B. The question is what goes with that data. So it's all the interference. And when you put these things on a device like a spectrum analyzer, and you can check, you know, at the different frequencies, you'll see that there's noise all over the place at very different frequencies. And those affect the Wi-Fi chain all over because it's all connected. So you have, you know, a music server, a computer, then it gets connected to a DAC, and then the DAC gets connected to the integrated amp or to a preamp, and then to the power amp, and then to the speakers. And that's all goes to influence the entire hi-fi chain. So that noise that originated first at the beginning, in the music source, gets to influence the rest of the hi-fi chain. So that's the basic principle. It's a very basic approach in terms of you want your source to provide a very, very clean signal into your, you know, into the rest of your chain, be it a DAC, be it a streamer. You want to make sure that you receive it as clean as possible so that those components can perform at their best. Now, how to achieve that is there's quite a lot of variables, but as you said, some are more important than others. One of the very first things we focused when we launched our second generation products are the power supplies. And I think this will probably come at no surprise for most audiophiles. We know already how much power supplies make a difference, even in the analog world. So on preamps, on amplifiers, and so on, they make quite a difference in that. What might be surprising for some is that why should they make a difference with music servers, and hence the introduction. So if it's just pulling out zeros and ones, then it makes no difference, then that's fine. But it's what goes with it. So particularly a lot of switching power designs, and on computers, they have this kind of nasty small bricks you just connect to the wall or something like that. They're made to be efficient, just not consume a lot of power and provide whatever power the computer needs, and that is it. They are not designed at all to say, oh no, I want to keep the noise levels really, really, really down. I just want to supply power. And again, that goes through the entire chain. So after that point, it's quite difficult then. You can try, and in some cases you can try and clean them up. So you can, but it's like it's so mixed into the signal, so into the different frequencies. If it was a question of eliminating like a specific frequency of noise, let's say, oh, all the noise is concentrated at 1 gigahertz, then that would be easy. We'd say, okay, let's put a filter on 1 gigahertz, job done. But it's just spread all over the place. It's like you're mixing ink with your water, and then you want your water back. It's not that easy. It's not that easy just to get it all back.
And another thing that I often talk about, and we talk about on the show, is that the times have changed in terms of what's flying through the air. Back in the day, when they first kind of, even with analog, you would get some interference, but if you go to any audio show, there's so much Wi-Fi, so much cell phone, this type of any type of radio waves, signal waves flying through the air, that it's pretty busy. The idea that there's no way interference could jump into the chain, I think, seems a bit short-sighted at times. I would assume, but I'm not an electrical engineer, so. So in your opinion, then, what are some of the best reasons for upgrading to a music server or a streamer outside of having it in there? Is the main draw that the unit has a separate power supply from the DAC that drives a lot of that, or you can just do it better with your power supply?
It's the quality of the power supply. So normally we use linear power supplies rather than switching power supplies. They are not the most efficient and they are not the smallest as well, but they are definitely the quietest. So and there's different designs that you can do for that. But I would say generically, the reason to upgrade to a music server, I believe, is essentially two. One is sound quality, which will be paramount for most people, but also one of convenience, and because you have something that it's purpose made for audio, where it helps you. So it's not just the hardware; it's the software as well. So it makes it easy for you to import your music, to manage your music, to play your music. Eventually even manage multi-room, so if you have several players around your house or different streamers and so on, you can play from that. But just even the simple obstacles, like you want to share music with your family, you don't really want to turn on a laptop, or you don't want to use it let's say your laptop. Perhaps you can do a dedicated laptop even, but if you do, and then do you leave it always on? Perhaps. Maybe you can leave it always on, and that's already a step forward. But these kind of music servers, they're really made to just be on all the time, so that anybody can use them. Grab an app, and then they're just ready to go. And again, the whole software itself as well to help people, choose their music, manage their music, backing up music, and so on. So managing the music library. So what we would like to do, you can see it more as an appliance. It's something that's there. You press on. It normally, and that's our objective, that it just works. So you don't have to think too much about it. You just put it there. Because if you put a laptop, then it's going to be connected via Wi-Fi. And then Wi-Fi, if you're streaming a lot, sometimes kind of messes up if you don't have a good router or a good Wi-Fi connection, and then it drops out, and then everybody starts getting frustrated because you had your friends at home and you were trying to listen to some music, and the whole thing couldn't play anything. So, in fact, this was actually the motivation to start the company, really. When I first started designing the initial music servers, I did it for myself as a kind of a hobby. And then I would have friends coming at home and say, well, that's really cool. You just grab your phone there and put some music. Where can I get that? Well, you can do your own, but there's a lot of trial and error. There's a lot of trial and error on that. So if you're kind of tech savvy, you can do something like this for yourself. But, if you just want to appreciate music, something like this just works. Just keep it there and you can just choose your music and away you go. So there is these two things, and they're quite interconnected, because obviously when we build the music server, besides the power supplies, there's a lot of other things that make an effect on sound quality. Even the software side, so the operating system, so having it very efficient, so it doesn't run. Normal computers run lots and lots of things. I mean, even either Macs or Windows, they're running lots of things because they're made to be generic computers. They're not made for audio. And that takes time, that takes CPU. Sometimes it will create interruption. I mean, for those who are, for instance, in pro audio, they will know that if they're recording instruments, you don't want, your antivirus to do something at the same time.
Yeah.
Because it's going to start cracking up your interfaces all over the place. So with the music server, it's the same thing. So it's fine-tuned so that those processes don't kick in. They don't. We don't need them. We just take them out. In the hardware, we do exactly the same thing. So we use custom motherboards now. We don't use off-the-shelf motherboards because there's quite a lot of components that produce noise, but they're not really necessary. We don't need it for audio. We might need it if you want to use it as a generic computer, but you don't need it for audio. So we just customize and take them all out. So that because they become simpler, they become a simpler motherboard. And here simplicity is key. The shorter the signal path, the simpler, the less components it go through, normally the purest the signal is.
So you had mentioned that you tinkered with a little bit early on. Do you have any kind of entry level low-cost music server solutions for those people, maybe like a DIY thing that you tinkered around with for people who want to start with their own thing, the computer-oriented people, like you said, and then as they get into it, they can obviously evolve into the more higher-end stuff that you guys produce. But what do you kind of recommend at the beginning parts of this?
Again, if you do have the time and if you're interested in doing it, it's a very interesting project, and I think it does open up horizons quite a lot. I mean, you can start with a fairly simple computer. I mean, a lot of people doing from things like Raspberry Pi, and you have softwares like Volumio. There's a few that are pretty much ready to be. You can check online and you can check the instructions, and it's fairly straightforward to get them all working together. So I would say that's the entry level, but we need to bear in mind that not all people that do DIY do it because they want a cheaper server. There's actually quite a large community of DIY builders who go quite advanced. They go with very high-end systems. They want to build their own because they want to tinker with it, and they want to try what's best and whether they can, if they change this for this kind of motherboard or this kind of SSD or this kind of Ethernet port. So it's not only for those who want a server on the cheap, it's actually for those who are interested in digital audio, and then they can take the next step. But for those who want to get started, I would say try and get a kind of a more dedicated computer or something. A Pi will get you started as well. You may have to know quite a lot of Linux for that. So you do need to have to be tech savvy in that sense, because if you have any issues, if it all goes well, then it's fairly straightforward. It's only when things don't go that well, it's like, okay, so now what I do?
Right.
So, but again, I believe the gateway to understand how much it can bring you is once you power it with a good power supply. Don't just use your Raspberry Pi or something like that and plug it into a wall, one of those wall warts. Try and get a good linear power supply for it. And I think that will give you already, I think the difference, if you just plug in the wall wart, have a listen, then plug in the linear power supply and have a listen, that by itself will give you a pretty good idea of what we're doing here. And then things start extending from there. So then you could start at looking more into the software part of things. You can start looking at the interface part of things. So optimizations around the USB, optimizations around the Ethernet. But these days, more and more, you can get this as add-ons. So even from Innuos, you could start, let's say, even with your computer, get a good power supply for it. Then if you're connecting to a USB DAC, we have something like the PhoenixNet, which is a reclocker, a very high-end reclocker to connect. That will help, for instance, getting a good signal even out of a computer. Or the PhoenixNet, which does a similar thing, but for Ethernet. So you can start adding building blocks. It doesn't have to be ours. There's others on the market. But you can start with these building blocks. So you can start building your solution, piece by piece. And I think, again, it's a very, very interesting project. And I think it will help you understand a lot more what us manufacturers do. Mm-hmm. And then, in fact, a lot of people have come from that, from developing their own music servers, and then at some point they say, well, you know what, I'm going to get an Innuos because it's going to save me work here, there, and there, or I don't have to maintain it that well. Guys can maintain it because software, for instance, needs maintenance all the time. Mm-hmm. So I just want to enjoy my music rather than just focus a lot. Maybe I've learned what I needed to learn with the project, and now I just want to be able to listen to music. Things like linear power supplies, they're not as easy to build at home. Anybody can get a Raspberry or a normal PC board and put it into a case and get it to work. Building a power supply, that's already a different set of skills. So if you do need, electronic engineering skills and be quite savvy with, at the very least, with soldering and getting a dedicated board done and so on. I would say in most of the cases you can DIY. If you want to go kind of the initial way, DIY computer, get like a good basic board, not too noisy preferably. How do you figure out it's noisy? Well, our view is the simpler the better. Something like a Nuke board, for instance, is a good, it's a small, simple board. An Intel Nuke, for instance, it's a good board to start with. And then you can start adding on. Get a good power supply. Get a good, maybe, again, if you use a DAC, a USB DAC, then get a USB reclocker and have a listen and see how that works for you. And then take it from there. It's only when you start getting more and more into the higher end, you'll start appreciating the things that done, the optimizations on the operating system, the fact that we have, for instance, several linear power supplies, not just one. Even the Zen, which is kind of middle range, already has 2 linear power supplies inside. Our statement has 8 linear power supplies inside, so they're all separated for the different bits and pieces. And that all makes a difference. Hence, I think this podcast is very well themed, because one of the benefits you get from using a music server is that it's the synergy of quite a lot actually, small modifications you do that add up together. Sometimes a single one doesn't make a lot of difference, but when you add up 20 or 30 of these, those are very audible. And we at Innuos, we concentrate a lot on that. So we want to make anything like we do, you need to be able to hear it in 5 or 10 seconds of music. If you're still kind of having a good listen and you can't hear a difference at all, then what's the point? I mean, maybe there is a difference, but if you need to listen for it for 5 times to get the difference, then there's not much of a point.
I really like that sentiment, because there's so much emphasis on measurements, and I wouldn't even argue that measurements wouldn't be an essential part of this whole process. But I like that you emphasize listening, and especially in your own system, right? Yeah. A lot of manufacturers talk about measurements, but when you're in the course of you building your own thing, it's so much about you. I would say you give it a listen. Do you hear a difference? If you don't, then move a different direction. But you're right. The cumulative idea that many of these things build together, I think it works on a broader sense too with these systems that we put together from the source to the speaker. There can be a real magic when everything works together in the right way. Absolutely. But the fact that it multiplies and multiplies is something I feel like that's often overlooked in the idea of building a system for audio, because a lot of times people just assume yes or no. It's more of a start or a stop thing. Is this good? Will this one thing save my system, or will this one thing completely change everything? And sometimes it does, but sometimes it's a couple of things at play as well. I'll admit that from my experience as well.
Absolutely. I mean, it's all about the synergy of the system. I don't think, again, I don't want to offend anyone who might actually do it, but you don't shop around for an amplifier based on the total harmonic distortion of that amplifier. You don't just go on a list and check, okay, I have 20 amplifiers here, let's see which one has the lowest THD. And whichever has the lowest, that's the one I'm going to buy, because that's going to be the better one. I don't think anybody does that. And again, even there's no such thing as a universally best amplifier. It depends a lot on your speakers. So if you use these speakers, maybe this amplifier will work better with those speakers. If you're using different speakers, maybe it's best to have a different amplifier altogether. And that's the whole synergy of the system. And it can only sound as good as your weakest link. Mm-hmm. Sometimes the weakest link can be something sometimes as straightforward as cables,
Or a connection. I was talking with a manufacturer who built tube amplifiers, and was saying that if you have a rusty or eroding connection on the tube, it can affect the impedance, and things can fall out of whack all over the place.
Absolutely. I mean, in a lot of cases, you have issues on the mains power supply of your home that make a huge difference in terms of sound quality. So it can only be as good as your weakest link. I think what's been happening lately with the rise, let's say now with digital systems, I think it was worse maybe 5 years ago. I think it's getting better and better. I think people are getting the message that indeed a music server is a part of the hi-fi chain. Mm-hmm. So it's not just, okay, here's a computer and then here's my hi-fi. It is part of the chain and it needs to be optimized as such. So it's been more and more the music server has been the weakest link, especially when you already have a pretty good hi-fi system. Mm-hmm. I've seen so many cases of people having systems, hi-fi systems in the hundreds of thousands of dollars and then playing from a laptop. And they're not going to get anywhere near what they can get. And then obviously they come back and says, well, you know, my turntable sounds a lot better. Well, that's no surprise. Yeah. You know, it's almost the equivalent of using like one of those cheap, I don't know, $30 USB turntables to play your records, which every time they read 3 times the vinyl, they'll ruin that vinyl.
I would say actually it's an interesting thing, but it's almost like saying you spend $10,000 on your turntable, but you buy like a $20 needle. You know what I'm saying? That needle, that point of contact.
Exactly.
You would not do that. You would not spend $10,000 on the construction, but have that thing that receives the signal be inexpensive. You would obviously budget some for the cartridge.
And again, these do make quite a difference. And we encourage quite a lot everyone to say, get to your dealer, and if possible, try it at home with your system. One thing is to actually, at the time when there were audio shows, we do exactly what you experienced, Brian. We put our different systems there. We can say, okay, have a listen with this system, and then everything else remaining the same, amplifiers, speakers, cables, and all that. Now try it with this system and try it with this system. So that at least people understand that there is a difference. And what kind of difference? What do they hear? Is it on the soundstage? Is it more organic voices? What is it? And everybody can make their own opinion because, this is about our brains. Mm-hmm. If it sounds better to me, it doesn't mean that it sounds better to you. Maybe you like it in a different way. So you need to have a listen for yourself. And what I can say is a lot of users who've just tried it at home, then they came back, and a lot of them were skeptical and said, look, you're right. I can't deny I'm hearing better. I don't know what you've done inside the box, whether you put some leprechauns in there, but whatever you did, I can hear the difference. My wife can hear the difference from 10 meters away from my hi-fi. Mm-hmm. Because that's an important part. You were mentioning just a while ago in terms of measurements and so on. I think both are important. The way we do our research and development is that we obviously cover for different phases. At the first stage, we do measure them. So we try to get on a oscilloscope and checking on different areas, trying to check EMI levels on different components and so on. But then it does need to go up and have a listen. Because you're doing that, but you're never really sure how much of a difference it makes. Okay, so your noise has gone down from 10 millivolts to 0.1 millivolts. Okay, seems like a big difference. But does it make a difference in terms of sound? Is it enough? You need to hear. For that, you need to test. You need to have a listen and then try and understand. Sometimes it does, sometimes it doesn't. So it's not all of it. And particularly, we even do 2 kinds of listening, let's say. So one is actually, sitting on the sweet spot right in front of our system, and we can, understand things like the depth and the sound stage and how natural the voices are. But one of the areas I actually find quite interesting, and this is reported by customers as well very often, is if you notice a difference while sitting somewhere else in the room, like 5 meters away, because that has to do with breath, with rhythm, with being at the right pace. It's the kind of thing that makes us tap our feet. And it's curious because a lot of customers sometimes they purchase one of our systems and then they send us an email and say, look, I'm really enjoying it. And it's amazing because my mate, whatever in the house, she's not an audiophile, doesn't know. But as soon as I start playing, she came in and said, wow, that sounds good. And that wasn't like sitting on the sweet spot and things like that. It's just sideways. So that makes a difference as well, and that's important as well because it's how it conveys the emotion of the music. It's not just the sound; it's also the emotion.
I think it's really interesting that you talked about the education of certain products because I feel like 10 years ago or even 5 years ago, the education was on the DAC. Right?
Yeah.
So we're like, what is this DAC? What does it do? Why is it important? And we've kind of, as a community, evolved now to where we're going even further back, saying, what about the music server? This is the education process now for a lot of audiophiles, where 5 years ago, the focus was on the DAC. And we say, why is that important? And that's why I think it's important now to look at this and say, well, why is this other essential part of the chain also important? And it's separate. It's a different thing. So I really like that. I did have one question for you as you were talking about your products, and that would be more of a granular tip for some of our listeners. But do you find that the use of hard cabling the Ethernet into the device provides better or any type of audible difference compared to doing it over Wi-Fi? Do you have a recommendation there? Is Wi-Fi good? Does Wi-Fi make a difference? Or because you talked about some of your Ethernet products. So I'm just curious about that.
Sure. Generally, Wi-Fi tends to be noisier. That's at least our experience with the product. Because one could argue, okay, it doesn't have a cable, so at least it's not transmitting any interference from, let's say, a router or anything else from the cable into the system. So I'm just putting an antenna. But the problem is exactly that. You're sticking an antenna right to the motherboard. And that antenna will not pick up just the Wi-Fi. It picks up every single source of noise. You have like a fluorescent light in your room, that will pick up the noise. I mean, again, in pro audio, people know that a lot. You know, if you use like single coil guitars and you have a venue full of fluorescent lights and all stuff, it picks up noise from all over the place. You can direct the guitar left and right, and it will pick the noise based on the source where it comes. So Wi-Fi antennas do get that quite a lot. So we do tend to avoid Wi-Fi because of that. Again, our ethos is don't produce noise in the first place, rather than let's try and clean up the noise that we do get. So eventually there are treatments that you can do to Wi-Fi to make it better so that you can filter some noise. But like I said, you're never perfect. You're always let things seep through. So it's a matter of what we call noise floor. Okay? So let's say you have a really, really nasty router that injects loads and loads of noise. If you put Wi-Fi, it might actually get better because you had something that was injecting quite a lot of noise into your system. But on the other hand, if your router is already fairly quiet, you have, good shielded cables and so on, then when to compare to Wi-Fi, you said, well, no, that's going to be a lot better. And that's our experience. We usually get a better experience, when you use it cabled rather than using it via Wi-Fi. I think as well for people, for instance, who use laptops, and I think this is a good tip, if you have your music local, just disconnect Wi-Fi while you're having a listen. Turn it off. Another thing that helps people, for instance, who use laptops, and this is we've seen this time and again, is that sometimes people have their music on USB hard drives. Try just copy it to the internal drive of the computer and then listen there and unplug the USB drive. And particularly if you're using that with a USB DAC, I'm pretty sure you will hear the difference because your hard drive will be injecting quite a lot of noise into the USB system. That's the same system your DAC is connected to.
My next question I had for you is what feature in the music streamer makes the greatest impact on sound quality? based upon what we've already spoken, I would say that's the power supply. Is there anything outside of that, maybe a second tier, or is there some surprise that you think makes an impact greatest on the sound quality from the music streamer?
No, I think again the one that makes the biggest, it's a bit like a pyramid. Okay, so the power supply is the base of that pyramid. That's the thing that you should improve first. Okay, once you have that sorted, then there's other things as well. Again, one of the things we've seen having quite a lot of impact, of immediate impact, is, let's say if you use a USB DAC, is the reclocker. So it's the clock itself that's being used, and how you send that power to your DAC. So because the DAC may or may not, some DACs do not require those 5 volts, some of them do. But even if they don't, if the USB signal going out to the DAC on the data lines, the 2 data lines, they will have interference as well. So a lot of people think, well, if I have a galvanically isolated DAC, then I'm sorted, right? Well, no, because the galvanic isolation typically is applied to 5 volts and ground. They're not applied to the data lines themselves. And that means that there's still a carrier for them to go through and to kind of affect that. So that's very audible. Again, on people who have tried our Phoenix USB, for instance, you can't deny, you hear it right away. So it is not subtle. But again, that already is a combination of both power supplies and clocking, and a very high precision clock for the USB. The Ethernet part as well is something that it's a bit more recent, and we've seen a lot of products in the market coming in this area now. But you can hear the difference just as well. Normally what we've seen is on the Ethernet, you normally already need a well-sorted system. It's something that it's not as immediately audible as something like if you have a good system which is already optimized with good cabling and all that. Once you put, let's say, this kind of audiophile switch, you will hear the difference more. And it will depend on the construction of these switches, of course, as well. But those are the kind of things that make an immediate difference. But then there's lots of other small things, again, that maybe by themselves don't make that big a difference, but from the isolation of the Ethernet ports, the software itself, how you run on our servers, for instance, when you play back from local files, we actually load everything into RAM first, and then we play from RAM memory. And this is so that there's not as much activity on the hard drive or SSD while it's playing music, because, again, that does produce some noise. Those are all important factors, but they're not big-ticket items. So those are things that you add up. When you start looking at the latencies, when you give priority to audio processes rather than other kind of home-keeping processes of the computer, all that all adds up a little bit more. So you're doing improvements even on the hardware itself. The frequencies at which some components operate, for instance, make a difference. But it's the sum of them all that then make a difference. What we see on our product designs is essentially it's power and it's timing. So it's the clocks, it's the timing of the signals, be it USB or Ethernet.
Very early on, I was reviewing a predominantly Blu-ray player, a CD player, and the CD player sounded fantastic, and and then also had like add-on streaming capabilities, and the streaming capabilities sounded great, but the USB did not sound good. The only thing, and I kept thinking at the time, like, there's so much good design inside this thing. And for that particular product, it was launched quite a while ago. I feel like the USB was an add-on device. But like I said before, it got me thinking, is it possible that something specifically about the USB can go wrong? And again, it's not that everything is going to make everything sound great. It's the idea that the weakest link is going to break this thing down for you. And you don't want a weakest link. And early on, I felt like there was quite a few issues with USB implementation. Now everybody's kind of catching up a little bit. It's a unique example where you were able to isolate just a little bit what this specific part from the rest of the system, because the rest of the system obviously was very promising, whereas the USB was like noticeably degraded. There just has to add at least some meat to the idea that USB audio is important and that it can go wrong, but you just like the predominant idea here is that you just don't want a choke point, right? You want all your stuff to be good all the way through. You want it every part, matters, right? Big or small. So, and I really do think the takeaway that you brought up from this episode that I'm getting at least is that the amount of gains that you get isn't always readily apparent, because sometimes it can be cumulative. There's value in the idea that cumulatively together, each part of your digital chain, each part of your entire system can start to make something a little bit more beautiful for you. And that's a really great point. I don't think that's really talked about as much.
Yeah, I'm looking forward to having audio shows again, because I think we can make these points very clear on demos. So, for instance, we can bring in a Phoenix USB, we can bring a Phoenix Net, we can bring our Zen, our Zenith, our Statement, and so on, and just plug in and unplug things. And say, okay, let's listen to this system with the Phoenix USB. Now let's have a listen without the Phoenix USB. Now let's listen to it with Phoenix Net. Now let's listen to it without Phoenix Net. And again, you can hear the difference right away, or at least we expect to be able to hear that right away. If you don't, then you're saving money. So that's not a bad thing at all as well. So, but the important thing here, and that's why we say we don't want to be kind of accused, you've set it all up so that it would sound nice. I mean, there's no point in doing that. People would buy this, if let's say they'd listen to the system and there's a big difference, and then they get home, they plug it in, and it's the same. It doesn't make any difference at all. So that's going to get returned or something. Or everybody starts saying, like, these guys are just selling snake oil or something like that. And nobody in the industry wants that. There's enough rumors about these kind of products that you really don't want to do that. So best thing, again, is try it at home. But let me just go back to the USB part there, because I think you made a very interesting point. I think with regards to the USB inputs, let's say on DACs, or when people connected to the USBs on DACs, they noticed that it wasn't that good. There was 2 points to that. So one is the source, which we've discussed before, obviously. So when they connected to AES and something like that, they used, let's say, a CD player, which normally you'll see that the better CD players already have pretty good power supplies. They're stable, they have vibration treatment, which is also a very important thing. They get vibration treatment. They are audio components, and they've been designed as audio components. Quiet power supplies, the linear power supplies, all of that. Then you compare with using a computer. Not fair. Not fair. So that's the first thing that you'll make a difference right away, and that sometimes gave the USB a kind of a bad name. But there's a second part, which is the USB interfaces on the DAC part. So the DACs themselves, normally the USB interface is a board which receives USB and then converts to an I2S signal, which then goes to the DAC. Now, a lot of manufacturers don't build their own boards. They tend to buy them because these need firmware. It needs firmware, so there's software development. There's sometimes there's FPGAs involved and things like that need to be configured. And they just get an off-the-shelf board that does this for them. So it doesn't have the same level of optimization that they put, let's say, on their SPD for whichever other input. But I think that's changing already quite often. I think one of the main advantages of USB is how good it is with all kinds of formats. Whereas SPD, if it's kind of more limited, you can't play, for instance, MQA over SPD as far as I know. So even DSD, feasible, but only to a certain level, I believe. So USB is quite universal in that you can put, native DSD up to 1024 if you want. There's MQA, there's PCM, there's DXD. It supports them all. It's quite a universal. So nowadays, DAC manufacturers, this is no longer, because a lot of them were seeing the USB input is whenever people want to connect this to computers. So we're not going to give, this is great if you want to listen to YouTube on the system. So they kind of put it as a lesser input, something just to connect a computer and to have a play with. Let's play some Spotify or something like that from the computer. That's completely changed now. People know that now, good digital sources will output via USB. So DAC manufacturers have stepped up their game considerably on that area. And we know quite a lot of manufacturers who've now put in their own implementations. They actually power those boards properly. They treat those boards for vibration, all of that. So they put the same kind of effort, at least, that they put on the SPDIF inputs, they actually put them on the USB now. And the results, you can see them right away. Nowadays, you have terrific DACs. In the past few years, there are terrific DACs out there. And it's been an area that it's been evolved. Every year, something new is coming in, which is breaking new ground.
So you mentioned that I2S is the internal language of the board. On a couple of DACs, I've seen I2S ports. Is there a reason that USB isn't circumvented in this way more often from server to DAC?
Well, you can, but you're actually just shifting the responsibility to somewhere else, really. So when you have an I2S input on a DAC, it says, okay, this DAC will receive a direct input for the DAC. Whatever I receive it on I2S, it goes directly to the DAC. I don't need a USB board. But someone needs to do that job. Okay? So if it's not the DAC, then it's the music server. So then you have to have a music server which needs to do that conversion right, because otherwise it doesn't mean that I2S is always best. It means that the implementation that you have now on the source needs to be really, really good. So in particularly with I2S, you do need to provide a clock signal with the audio itself. So this means you need to have really good, and you need at least two clocks, for 44.1 and for 48 kHz. You need two different clocks working, really good clocks, very well powered, in order for you to use, or at least to get the best results out of I2S. So actually, we're just shifting a responsibility. We're taking a board that's normally inside a DAC, and then you have to put it on the music server side. But it's not a universal thing that, I2S is the best input. It's going to get you the best sound. It depends on your implementation. Again, it depends on how you implement it. There is no such thing as the best input. I don't think anybody can say, USB is the best input, or let's say Ethernet is the best input, or AES is the best input. It doesn't matter. It depends on the implementation. For that product, maybe this one will be has the better implementation. But it's a combination of both. Because if I use a really good USB implementation on the DAC and a really crappy implementation on the music server, it's still gonna sound like crap. The same thing that you could say, I want to use a DAC that uses AES, but that I connect that to an SPDIF, let's say, and I connect that to a really bad CD player, like a really $20 or $30 CD player via optical output. And then you plug in USB to a really nice high-end system, and that's gonna blow the optical out of the water anytime, anywhere. So again, it all depends on the implementation. There's no absolute best on this. And on some systems, Ethernet will work best. On some, USB will work best. On some, AES will work best.
That's a great consideration to have. Not only are you want to deal with the receiving end, but you also should be conscious of what happens with the sending end of every right part of the chain as well, especially on the digital side. I find that really cool because I feel early on USB got a bad rap because of these short-sighted comparisons. The blanket statement is what I always kind of had trouble with, because very early on, people would be like, I plugged in my turntable, and it was always the turntable because it was an old school audio file, right? I plugged in the turntable, I plugged in the USB thing, and USB sounds like this, right? They would assume that all things, because of this one thing, was the same, but no one would say that about a turntable because of all the parts of a turntable. People talk about the tone arms, people talk about the cartridges, they talk about the plinths. To allow such a blanket statement to go unchecked, I always felt was a bit unwieldy for the whole idea of comparison. So
absolutely, and sometimes even the DACs. I mean, sometimes when they have these super expensive needles, cartridges, phono stages, and then they get a computer with a $30 DAC. I mean, come on. There's no. It's not a miracle kind of thing. It's not like, oh, now you can get for $20 what you used to get for 10,000.
Sigma Delta got a really bad rap from some people. Yeah. They would say, these, because ESS got a lot of traction early on, and them AKM, but people were coming on again saying these blanket statements. ESS DACs don't sound good. That's where I think we get into a little bit of trouble, because I've heard very expensive ESS DACs sound very, very good. But in the early days, I also would admit that I heard ESS DACs that didn't sound very good, but I wouldn't lay the blame specifically on that company at any of those given time periods.
And that's because a DAC itself is not just the chip.
Right.
The chip is a small part of the DAC. I mean, in fact, the analog stages, the power supplies of the DAC are extremely important, probably even more important than the chip itself. So you can't generalize that way. It's not because it uses this kind of chip that it will sound good. It's the whole implementation that you have to take into account.
Is there any simple way to explain what a reclocker is and what it does in a few short words? Because I realize this is a very complicated subject, but
sure.
Is there a way to kind of spoon feed us less inclined?
Yeah, sure. I mean, let's take USB. So what we do is we receive a USB signal, and the USB signal has two components. There's the data part, and there's the power. The power part we completely cut off. So we replace that with our own internal power, from a cleaner power supply. With the data part, what we do is we use a very stable clock, which is it's an OCXO. It's an oven-controlled temperature clock, so that it's very, very stable. And just to give you, these are numbers, but it just gives you a kind of an order of magnitude, just to have an idea. A typical computer-based clock for USB has a precision of about 30 parts per million. Okay? The precision on a clock on the Phoenix USB has 3 parts per billion. So it's a completely different order of magnitude. So these will not only provide a signal that has a lot less jitter into the DAC, but also there's less phase noise that affects the clocks that are on the DAC themselves. Okay, so basically that's what the reclocker does. It picks up the signal, in our case, it takes out completely the power side, and then the signal, it retransmits them again, the same signal, it retransmits them, but with much better clocking on it. It's a much better timed signal. If you allow me just for a quick topic as well, I think a lot of times people ask us, do I need to have a very high-end system in order to be able to hear this? Well, I can tell you one thing. We test our products on the whole hi-fi chain there. It's worth about maybe $2,500. Mm-hmm. Some of you might think, okay, that's expensive, but probably in audiophile terms, you'll know that it's not that expensive. Okay, and we can hear the difference between every single system we do, and we can hear it right away. So no, you don't need to do that. And again, if you have like a pair of like we use quite a lot a pair of LS50 wireless speakers from KEF, and they're quite versatile. And one test that if you have one of these or if you can try them out, a really nice test is, connect via Bluetooth or Wi-Fi to your phone and use it for that, and then connect a music server and play it again. And you'll be able to hear the difference it makes on having things like, because a lot of people just do that, just Bluetooth into a DAC or something, and away you go. But then when you connect a music server, it makes a real difference.
Very cool.
But again, I'll just say, if you have the chance, give it a try. Do it yourself. I think it's a great project. I think it's a great learning tool, so that to learn all the variables. Well, not all the variables, because I don't think anyone really knows all the variables just yet. I think we're all still learning. It's a great way to gain understanding of what makes a difference, and then you can choose for yourself. Maybe you get really thrilled and go to the high-end DIY side where you're going to try cutting-edge things, or maybe you just say, well, you know what, now I understand everything that it does, and I can actually appreciate better what a music server, just getting a ready-made, let's say, music server will bring to the table.
Nuno, thanks again so much. I really appreciate your time today.
No problem. Thank you very much for having me, Brian.
You're welcome.
And I hope to see you all soon at hopefully some audio shows this year. Let's fingers crossed on that.
I would love that. The Occasional Podcast is a production of the Part-Time Audiophile Network, which includes parttimeaudiophile.com, The Occasional Magazine, the PTA newsletter, and audiohead.com. You can stay in touch with us on Twitter, Facebook, Instagram, and YouTube. The Occasional Podcast is produced and hosted by Brian Hunter, executive produced by Scott Hall at PTA Productions. If you haven't already, please subscribe to The Occasional Podcast on iTunes, Google, Spotify, or wherever your favorite podcasts are downloaded.